Well, I see you. Hello there. Come in, grab a chair, get yourself comfortable. We're ready for another edition of Lopezlandia, where all our topics are about math. Let's move on. Remember, we have a test coming up, all right? Make sure you study. So, we have the rule for an arithmetic sequence. So, remember, this is how you find your rule for your arithmetic sequence. Remember what all of those parts represent. The a sub 1, remember, that's going to be your first term. The n are going to be the number of terms, and then the d, that is your common difference. Copy it down. Make sure you have your pen, pencil, calculator notebook. If you don't have a calculator, open up Desmos. Write a rule for the nth term of the sequence. 3.5, comma 3, comma 2.5, comma 2, comma 1.5. All right, you need to come up with the common difference. So the first thing I'm going to do quickly is label it a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Remember, it is a sub 2 minus a sub 1, a sub 3 minus a sub 2, a sub 4 minus a sub 3, etc. Okay? So don't forget about that, okay? And so when you do that, you should have a common difference of negative 0.5. Now we're going to put it into our rule so we could come up with a rule for this particular sequence and substitute accordingly. So make sure you substitute your first term and your common difference in there, and then start simplifying everything. So our rule now for this sequence would be a sub n is equal to 4 minus 0.5 n. All right, now we need to figure out what a sub 12 would be like. Actually. So go ahead and substitute. So n now is going to be 12, and substitute and simplify. When you do all of that, you should end up with a sub 12 equal to a negative 2. Let's move on. Arithmetic series. That's going to be the sum of the terms in the arithmetic sequence. All right. The formula to find the sum of a finite arithmetic series will be all of that. Again, this is for the sum. We're looking to add up all the terms in a particular sequence, okay? Make sure you have that ready to go. Not finding the rule. You're adding everything up, technically. All right. We need to find the sum to that. So, in order for us to use this formula, we need to figure out what a sub 1 and a sub 150 will be. So, the first thing we're going to do will be substitute in here. It'll be 5. Why? What do we do? Remember, this is going to be 11 times 1, the n value, minus 6. And that's how we get the 5. Same thing with this. This was 11 times 150 minus 6. All right, that's where we're getting that from. Now we could go ahead and substitute into the formula. Simplify, make sure you're using your calculator and checking your work. So we should end up with 123,675. All right, what about a rule? A rule for geometric sequence. This is how we're going to find it. It'll be a sub n is equal to a sub 1 times r to the n minus uno power. Make sure you have that, please. R is your common ratio. Remember that. And let's continue. Let's try an example here. The term of the geometric sequence is a sub 4 is equal to 3. The common ratio is r equals 3. We need to write a rule for the nth term. All right, so we know that a sub 4 is 3. So we know that n is going to be 4. All right, we got to use our little formula to figure out the rule and to find what a sub 1 is. So let's go ahead and substitute what we already know. So we substituted here, and now we need to simplify. So 4 minus 1 will give me 3. So it'll be 3 to the third power, right? Which is 27. So now we have 3 is equal to a sub 1 times 27. Divide out that 27 from each side. And when you do that, you should be able to simplify and get 1 over 9 is equal to a sub 1. All right, now we're ready to plug into our rule. So now to come up with our rule, it'll be a sub n is equal to 1 over 9 times 3 to the n minus 1 power. All right, now we need to find the sum of a finite geometric series. All right, so this is going to be another formula. Make sure you write it down also. We've gone over this too. Make sure you label all parts. So the n being the number of terms, a sub 1 being the first term, and r is being your common ratio. Let's try an example. Express each series in sigma notation and then find the sum. So we have 75 plus 15 plus 3 plus ... And they're telling us that we're going to have 10 terms. All right, so again, I'm going to go ahead and label parts of this. A sub 1, a sub 2, and I'm going to go with a sub 3. All right, what do I know? I know that a sub 1 will be 75. I could figure out what the ratio is. Remember, when you're finding a common ratio, it would be a sub 2 over a sub 1. It would be a sub 3 over a sub 2. It would be a sub 4 over a sub 3, etc. That's how you would find the common ratio. So for us, it would be 1 over 5. All right, let's go ahead and put it in sigma notation. So for our index, for a starting point, we should have 1. And then our last term should be 10 because they told us up there that we were going to have a total of 10 terms. All right, and then we're going to go ahead and substitute accordingly into our little formula. Now we have it in sigma notation. Great. What else do I need to figure out? I need to find the sum of all of this. So I need to use the other formula now to find the sum of all 10 terms. We don't want to do it by hand. That's too much. Let's take a little shortcut. Be careful with your fractions, please. Be careful with your parentheses. Make sure you use it accordingly. All right. And you plug it into your calculator, nice and neat. So if we add all 10 terms, we should end up with 93.75. Binomial theorem. All right, this one was that long one that it was just a little bit of a headache to do, but it was fine. All right, so we were expanding binomials, remember? And we were paying attention to the exponent. We had an R term, we had an A term, that sort of thing. All right, so the thing that you need to remember is that R is always going to start at 0 each and every time. The n that we have here is the same one from the exponent up there. Make sure you remember that. Let's try an example again. Okay, so things that you need to remember here. So this part right here, that is your A part. That part right there, that is your B part. And then you're going to go ahead and start substituting accordingly. Okay, so remember it'll be n is your 4. Is that exponent of 4? That, oh snap, sorry. I already gave you guys the answer. N is 4. So we're going to start off with, I'm going to show you again how to do this. Okay. And then we're looking at my A term. So this is going to be x cubed to the 4 minus 0. And then we're going to have 2y to the 0 power plus 4, choose 1, x cubed, 4 minus 1, and then times 2y to the 1 power plus 4, choose 2, x to the 3rd power, 4 minus 2. And then we're going to have 2y to the 2nd plus, I'm going to write it right below because I'm writing a little big. 4, choose 3. It's going to be 2y to the 3rd power plus 4, choose 4. Four minus 4, and then we're going to have the 2y to the 4th power. At this point, you're going to go ahead and simplify. Make sure you put in your combinations into your calculator, and then you're going to simplify. And at the very end, you should end up with x to the 12th plus 8x to the 9th times y plus 24x to the 6th, y to the 2nd plus 32x cubed, y cubed plus 16y to the 4th. Make sure you have all of that, okay? All right, let's try another one. Now we're getting into the probability stuff. You randomly select 2 cards from a standard 52 card deck. What is a probability that the first card is not a face card? So we're talking about a king, queen, or jack. And the second card is a face card if, let's look at letter A. So letter A says you replace the first card before selecting the second. Okay, so it's that card that you pulled out initially is going back into the deck. So now you need to determine if this is going to be mutually exclusive, not mutually exclusive, if this is independent, dependent. All right, to me, it sounds like it's going to be independent. All right, so make sure you have your probability formula for independent and you're substituting in. So it'll be 40 over 52 representing the first event, and then 12 over 52 representing the second event, and then multiply straightforward. Simplify simplify if you can, or give it to me as a decimal. All right, if I look at letter B, you do not replace the first card. Okay, so the second probability is dependent on the first one because now that card isn't going back into the deck. All right, so this is going to be dependent. Sorry, I forgot to show it to you. This is going to be dependent. And this is going to be the probability of A and B. Write down your formula. We're substituting in now. So we still have 40 over 52, but now it'll be 12 over 51 because remember, that card isn't going back in. Multiply still straight across and simplify if you can. And give me a decimal if you can, or leave it as a fraction. All right. How do you know if it is and, or probability? You have keywords here. For and, it's going to be both, all, etc. For or, it's either, at least, at most. All right, permutations again. You have your little formula. Remember, permutation. The order does matter here. It does. All right, so if we look at this one, from 12 skiers, how many ways can first, second, and third place be placed? So order does matter. It matters who's going to come in first, second, and third. So this is going to be your permutation. You should be able to come up with your N value and your R value. You have 12 skiers. Your R is going to be 3 because you have 3 different places that they're going to be in. All right. Simplify. And then we should end up with 1,320. Okay, you also have combinations as well. We've dealt with these also. And remember the thing here, combinations, order does not matter. Order doesn't matter. So now we have an example here. The swim team has 8 swimmers. 2 swimmers will be selected to swim in the first heat. How many ways can the swimmers be selected? So again, you need to come up with your N and your R and then substitute accordingly and simplify. All right, now we have mutually exclusive events. Remember, mutually exclusive, things are not in common. We do not have anything in common. And then our formula is there. All right, so it's going to be the probability of A plus the probability of B. So an example of this would be one 6-sided die is rolled. What is the probability of rolling a multiple of 3 or 5? Well, there's no way it could be both, right? So this is going to be mutually exclusive. So rolling a 3, a multiple of 3, because it's 3 and 6, so that's 2 out of 6. And then a multiple of 5 would be just the 5, so 1 over 6. Simplify, and you should get half. Now, for not mutually exclusive, remember, things are in common. You do have a common ground. And the difference between those two formulas is the fact that for not mutually exclusive, you need to subtract out what they both had in common. All right, let's look at another example. All right, one 6-sided die is rolled. What is the probability of rolling a multiple of 3 or a multiple of 2? So identify your events. Multiple of 3, you have 2 different outcomes because you have the 3 and the 6. Multiple of 2, you have 3 different outcomes because you have 2, 4, and 6 as your possible outcomes. And then you have some common ground here, all right? Let's go ahead and plug it into our formula now. So you should have 2 over 6 plus 3 over 6 minus the 1/6, which is 2 over 3. Make sure you always simplify. All right, we're done for today.